All right, guys, welcome back. Mr. Lloyd here. I'm working on Tuesday. It's going to be 317, and it's 3 pages, just like every day is going to be 3 pages to start out here. So the work I've got today here looks like this. I'm going to show you how to solve these quickly on the whiteboard. The first problem asks us to use the distributive property. We're going to distribute here 2 to k and -3, so of course that ends up being 2k minus 6. Remember, the parentheses imply multiplication. Part B is 4j plus 8, and of course it is just simply 4j plus 32, and then part C asks us to go and distribute x to both 2 and -x. So 2x minus x times x isn't going to be 2x this time, it's going to be x times itself, or x squared. Okay, pause it to reset. All right, so we're back. We're on problem 3, and here are our problems. Here we're going to take each one, a, b, and c, and we're going to find the common factor that each term has, and we're going to pull out that common factor. So our answers will have parentheses that imply multiplication by that common factor. Here, 2k and 6 have the common factor of 2. So I write it as 2 parentheses, and then, whoops, need to scoot my board over a bit here. So 2 parentheses, and then what times 2 equals 2k? It's k. And then what times 2 equals 6? Of course, it's 3. Okay, same thing. I'm going through these quickly. You'll need to pause the video if you need to take pause, rewind. That's the nice thing about technology, is that you can use it to your advantage in that way. 32 and 4j have a common factor of 4. I pull out 4 and I get 8 parentheses, 4 parentheses 8 plus j. Here, problem C, we pull out the common factor between 2x and x squared. That common factor is x. 2 times x equals 2x, and x times x equals x squared. So those problems A, B, and C look just like the other problems A, B, and C. Pause real quick. All right, so the last problem on this page gives us a table. It gives us 2 algebraic expressions. My dogs don't agree with either one, but they're just going to have to chill out for a minute. It gives us 2 algebraic expressions. The problem tells you from the get-go that these 2 are not equivalent. You're going to fill in the values for the table here to show yourself that they're not equivalent as well. So here we've got values for r. We'll substitute those values in for each equation. We'll just do one column at a time. 1 goes in here. 1 plus 3 is 4 times 2 is 8. I'm just going to keep filling these in. Again, you'll have to pause and check. Pause, double check the video, double check your work, make sure that I'm being accurate, but you can also trust me as well. So when r equals 1, this expression equals 8. When r equals 2, this expression equals 10. When r equals 4, this expression equals 14, and so on. Let's move over to the other column here. 2r plus 3, even though they look really similar, they're not equivalent. They don't have the same value. We'll find out real quick. 1 times 2 equals 2, plus 3 would equal 5. 2 times 2 is 4, plus 3 would equal 7. 4 times 2 is 8, plus 3 would equal 11, and 15 times 2 is 30, plus 3 would equal 33. So notice, if these were equivalent expressions, we'd see the same values or equal value in each column. We don't see that, so we know they're not equivalent. Okay, this is video 1 of 3 for March 17th, Tuesday, and I'm trying to make sure I'm not in the way of the date. I'm still getting used to this, guys. Thanks for being patient. I'll have the next 2 videos up shortly. See you next time.